Hi everyone! Today we're going to spend a little bit of time talking about how we observe matter in chemistry. So we're looking at really physical and chemical properties of matter and how we describe those properties, and then how we would identify physical versus chemical changes. Go ahead and title your notebook. Title your notes in your notebook, Observing Matter. This is our second learning target in Unit 1. Let's get started. So our physical properties, anytime we see a physical property, this is anything that can be directly observed and specifically without causing any change to the matter. So think when you're observing something using your five senses. So sight, sound, taste, touch, and smell. This is a lot of the things that we've seen so far when we were talking about observations. So anytime we can see the color, hear a chemical reaction if it makes a noise, feel something if it's rough or smooth, smell if there's an odor. Those are the physical properties of something. And so here are some good examples of physical properties that we see when we're describing substances in chemistry. So how hard something is, the hardness, the flexibility, can I bend it easily, the brightness, if we're looking at the light or a glow or a flame, the boiling point or melting point of a substance. So here when we're looking at our different elements and our compounds, the boiling point and the boiling point and melting point can be important physical properties of those substances. Density, so how much matter there is in a given area. The length of something. Fluidity, so how easily it flows when we're looking at liquids and things. Is there an electric charge? The pressure, the volume, the area. Conductivity means can it conduct electricity? So a lot of times metals are good conductors. Luster, that's how shiny something is. Some of these we've seen before, some of them are a little bit new to us, but we're going to see them a lot throughout this year. Chemical properties are a little bit different. So this is the substance's ability to undergo some sort of chemical change, a change in the chemical makeup of that substance. So this is any property that defines how it can behave chemically. So for example, we see here at the bottom, zinc reacts with acid. So often we can identify zinc as a metal by adding acid to it, and that will tell us if it is in fact zinc. It can help us to identify that metal in nature. The rusting of iron, that's telling us how does it behave chemically in certain conditions. Some chemical properties would be heat of combustion. So that's how hot do I need to get it in order for it to basically catch on fire or explode. The reactivity with water. So for example, sodium is very reactive with water. pH, that's how acidic or alkaline something is. Flammability, how easily can it catch fire. Toxicity, so this is talking about like humans if we ingest it. Chemical stability, so in oxygen, is it going to break down or corrode over time, or is it really stable? Things like gold are really chemically stable. And then the enthalpy of formation, that's how much energy does it take in order for that chemical to form in the first place. So along with physical and chemical properties, we can also look at how does matter change. And so matter can change physically or it can change chemically. So physical changes, this is when we see a change in a substance, but it's still the same substance. So for example, here I have some solid copper in the form of wire. And if I heat that copper up, then I can melt it and make it into a liquid. A lot of times when we're looking at physical changes, we might be bending something, crinkling something, or changing state between solid, liquid, and gas. Those are typical physical changes. So here we can see physical changes in the form of changing state. So when something changes from a liquid to a solid, we call it freezing or solidification. When something changes from a liquid to a gas, that's evaporation, evaporating. Those are really common. So solid to liquid, we can think about that with ice. When an ice cube changes from a solid to liquid water, that's melting. When a gas changes into a liquid, that's condensation or condensing. The weird one here is when we change between solids and gases. So when a gas becomes a solid, so oftentimes we think like frost in the morning is a great example of this. Gaseous water in the air, deposition occurs and forms solid ice crystals on grass and things. That's what frost is. And then we see the opposite, sublimation. When we go from a solid straight to a gas, sublimation occurs when we think about dry ice. So that's solid carbon dioxide converting directly into a gas version of carbon dioxide. Chemical changes are different because chemical changes are when a brand new substance is formed. Great examples of chemical changes are often related to baking. So if I add all of the ingredients for brownies together, if I add the flour and the baking soda and the sugar and the chocolate and the eggs and the oil, and I bake them in the oven, a chemical change occurs and they form into a new substance. So all of those individual things form into a new substance, which is the baked brownies. We also see a lot of chemical changes in chemistry. So there are a lot of different signs, some indicators that chemical changes have occurred. So if we're mixing chemicals together, we're mixing things together and we notice that heat is either given off or taken in, that is a sign of a chemical change. So endo, meaning into, thermic, that's talking about heat or temperature. So taking heat really in, that's endothermic. So we can see that here. Okay, versus exothermic, exo meaning out of, so giving off heat. That's what we see here. When chemical reactions are giving off or taking in heat, that can often be an indicator that a chemical reaction has occurred. A formation of a precipitate. Precipitate is a fancy chemistry word for a solid. Usually when solids are forming in chemical reactions, it's forming on a molecular level, and so it looks more like a powder suspended in the solution. So here we can see the kind of like the little chunks. That is the formation of a precipitate or a solid in the solution. We can also see indication of a chemical change when a gas is formed. So here we have a liquid and a solid, and when we put that solid, that's a little piece of chalk, which is usually calcium carbonate. When we put that into this liquid, which is probably some sort of acid, it forms bubbles. So the formation of that gas, that bubbling, is an indication of a chemical change, because we've formed a new compound or a new molecule that is a gas state at whatever that temperature is. And finally, we can see often a color change will be a good indication that a chemical change has occurred. So here I see two clear, colorless, translucent liquids. When you mix those two together, they form this yellow. In this case, we actually see a yellow precipitate. So that's powdery solid is formed in there, but we also see that color change. And so that color change is a good indicator of a chemical change. All right, go ahead and answer the question here at the end. Leave any questions that you have for me that you would like me to answer when I see you next in class, and have a good day. Bye.